Welcome back. Now it is the time to deep dive into the concept of variables and learn some advanced topics. Let us start with an example. Suppose we have these statements in our program where a is equal to 7 and b is equal to a. And then we say print b. What will be the output of this program? Take a moment, pause the video and come back with the result. Do not run it as of now. The output of this program will be 7 because the variable b gets the value of a, which is 7. So far so good. Now let's try to understand how it happened. First we said a is equal to 7. So the variable a started pointing to a memory block having value 7, right? After that, when we said b is equal to a new variable b got defined which also started pointing to the same memory block as that of a. Therefore, when we said print b, it printed the value of same memory block which was 7. So the output we got is 7. Okay. Now we change the program slightly. Let us say a is equal to 7, b is equal to a, and after that we say a is equal to 5, and then we say print b. Now what should be the output of the program? Again, pause the video, think about it and come back with your result. Just don't run it as of now. Now if your answer is 5, then I am sorry, the answer is not correct. The correct answer is 7. Why? Let's try to understand that. As per our current understanding, a and b are pointing to the same memory block. So when we change the value of a to 5, the value of b should also change to 5, right? But it does not happen that way. Let's understand this. As long as only the first two statements got executed, that is a is equal to 7 and b is equal to a, the variable a and b were pointing to the same memory block. However, as soon as we said a is equal to 5, that is we changed the value of a, then a left behind the old memory block and a new memory block was allocated with value 5 and variable a started pointing to the new memory block. However, the variable b was still pointing to the old memory block. Therefore, when we said print b, we got the result 7 and not 5, right? So this discussion leads to two important aspects in Python which we will discuss next. The first concept is that the integers are immutable. By immutability, we mean that once an integer variable is assigned some value, it cannot be modified. It does not mean the value of the variable cannot be changed. It just means that the value contained in the memory block to which the variable is pointing to, it cannot be modified. Do not worry if it is not clear as of now. Let's try to understand it using an example. So consider this statement a is equal to 7. So for this, the variable a is pointing to a memory block containing value 7. Now let us say we change the value of a to 5. As soon as this statement gets executed, the variable a, it starts pointing to the new memory block containing value 5. So as you noticed here, the memory block with value 7 was not updated for new value 5. Rather, a new memory block was allocated with the value 5 and the variable a started pointing to this. This is the immutability property of integer variables. And this property is applicable to float and boolean variables as well, which we will discuss in the upcoming chapters. And there is one other important point here as well. When we said a is equal to 5, what happened to the memory block containing value 7? Actually, it got freed. Since this particular memory block was not being referenced by any particular variable, it got free. Since it got freed, it became a candidate to be collected by garbage collector. Garbage collector keeps on running in Python and it collects all the free spaces. Because this particular memory block was free, so it is collected by a garbage collector. Now coming to the next concept. So far we discussed the integer variables having decimal values. However, as we know that in computers, everything is in binary, that is containing zeros and ones. So the integer values are actually stored in binary formats. It is just that they are being displayed in the decimal format. Python provides a few functions to convert a number into different formats, that is binary, hexadecimal and octal formats. Python also provides one function to extract an integer value if it is in string. We will study string data type in the later chapters of this course. The function name through which we extract the integer value from string is actually int. We will study this function also in our later chapters. So with this, thank you for your time in this chapter. Thank you.